You are trying out for place kicker on a football team. A ball is placed 50 meters from the goalpost. The crossbar is 3.05 meters high. You kick the ball with an initial velocity of 25 meters per second at 30 degrees. What are the x and y components of V0? We'll have several other questions too. So here's my football. Right? Here's its trajectory. Here are my goalposts. This distance is 50 meters. This height is 3.05 meters. My initial velocity, V0, is 25 meters per second. And my initial angle is 30 degrees. The first question is, what are the x and y components of V0, right? And so we need to find those components, and they look like this. There's my y component, right? And here's my x component. Right? And so V0x is equal to V0 cosine of 30 degrees, right? Because cosine of theta is adjacent over hypotenuse, which is V0x over V0, right? And this gives us 25 meters per second times the cosine of 30 degrees. And if we calculate that, we get 21.7 meters per second. Similarly, V0y is equal to V0 sine of 30 degrees. The sine of 30 degrees is an easy one. It's a half, and so 25 meters per second times a half is 12.5 meters per second. That was part A. Okay, let's do part B. Okay, part B says how long does it take the ball to reach the goalpost? And so once again, here's our picture. Right, ball travels this angle, this trajectory, and eventually it reaches the goalpost. And we want to know the time, right? And so, what is the time? Right. Well, we know that V0x is equal to 21.7 meters per second, and we know that the x velocity never changes, right? Vx is equal to V0x. So really the x equation for horizontal motion, for a projectile, is x equals x0 plus V0x times time. Right? In this case, we can pick our x0 equal to 0. We're free to choose it. And so this gives us x equals V0x times time, or time is equal to x over V0x, which is 50 meters divided by 21 point, whatever we calculated in the first part, 21.7 meters per second, which is 2.3 seconds, approximately. So that's the time it takes to reach the goalpost. In part C, we ask, is it good? Meaning, does the football cross the goalpost above the crossbar? Is y greater than 3.05 meters at the crossbar? Right, here's our football. Right, here's its trajectory again. Here's our goalpost. Right, where does it hit? Does it come through down here? Does it come through up here? We don't know. Right, we do know that the time here is 2.3 seconds. And so we want to know, well, how high is the ball at this time? Right, and so the equation that jumps up for this one is y equals y naught plus v naught y times time minus 1/2 g t squared. This is the height of the ball at every time. We can just pick y naught equal to 0, just like we did in the last problem with x naught, and drop that term out. And then we have y is equal to 12.5 meters per second. Again, that 12.5 is from part A, times 2.3 seconds minus 1/2 times 9.8 meters per second squared times 2.3 seconds squared. And what we get for y is 2.8 meters. So, no, the ball passes under the goalpost, and the kick is not good. But since you're trying out, you probably get 10 more kicks, and if you make the next 9, you'll still make the team. So the last part of the problem is, how far behind the goalpost does the football land? Right. So here's our football. Right. It's fired at the goalpost, and then it lands somewhere beyond the goalpost. We know that this distance is 50 meters, and we know that it passed below the goalpost because the height was 2.8 meters and the goalpost was 3.05 meters at the goalpost. But we want to know this distance, right? So we could say, look, y equals y naught plus v naught y times t minus 1/2 g t squared. And ask, how long does it take to hit the ground? Right, then we could take that time and put it into x equals x naught plus v naught x times the time. Because we know all of these things. The initial height is 0. The final height, if it's landing on the ground again, would be 0. So we know both of those. We know the initial y velocity. We calculated already. It's 12.5 meters per second. We know g, so we can calculate the times, which is at the ground, and that would tell us the time. And then we could plug that in here, because we know the initial velocity. That's 21.7 meters per second. That's the initial x velocity. And we know x naught, we can just set that equal to 0. But there's an easier way to do this one. So we could solve it this way if we want to, but we won't. This formula, this problem can be solved with our range formula. If you remember, the range is equal to v naught squared sine of 2 theta over g. And so we write that over here. Our v naught was 25 meters per second. Our sine of 2 times theta. Theta is 30 degrees. That's 60 degrees. So it's 2 times 60 degrees. Sorry, 2 times 30 degrees, or 60 degrees. I'll write it as 2 times 30. 2 times 30 degrees over 9.8 meters per second squared, right? And so that's equal to, sorry, this thing is squared. So it's V naught squared sine of 2 theta over g. V naught squared sine of 2 times 30 divided by 9.8 meters per second squared. That's 625 meters squared per second squared times sine of 60 degrees divided by 9.8 meters per second squared. So our range is equal to. So what I get for this is 55.1, sorry, 0.2 meters. But the question is how far behind the goalpost. And so since the distance to the goalpost is 50 meters, the final distance is 5.2 meters.